from your favorite artist electronist, Mr. Q12. All right, what I'm having here is a bistable circuit with the minimum with the minimum components possible. So this is a bistable flip-flop or astable multivibrator. It's having two names, but it's really the same thing. And everything, this is the minimal circuit that you are seeing here. Here is the diagram for this circuit that you are seeing here only. Here. This is the one. So not this. This is a simplified version, which didn't work directly. The signal was very weak here. But here in this diagram is amplified by this transistor, and you can see that SMD transistor there. And this is an auto flashing LED. It's not or auto blinking LED. And I use it as a clock in my preview video. It's a cheap, extremely cheap clock. And then I have another second version, which is this, which is a bit more powerful. It's with opamp LM358. This is a SMD version because you can see that white mark there. This opamp was scrapped but I have a lot of them brand new, also in SMD shape and size, like this one. But this one specifically, it is scrapped and it's working absolutely fine. If that's the LED, that's the resistor. You see exactly like in diagram. And I used this gate from this side of the chip, and here is a positive negative rail to power the integrated circuit. It's only one input here, and it's from this pin. And I drag a wire underneath it, I believe. Yeah, you see the wire? There it is. You can barely see it, but it's there. You see it? Here it is. This wire that is going here is going here between the two. Okay, so I originally tested the bistable circuit with this circuit that I'm having here with the opamp, and I said, well, this is a bit too powerful for this kind of circuit, and let me test it with the weaker one that I'm having with the transistor. When I'm saying it's powerful, it's not that it's raising the voltage too high. You can see the markings here. It's the maximum voltage is 4 volts. I got different results in different tests. That's why you see 2 voltages here and here. But most of the case, and normally it should work at 4 volts, and the minimum voltage is almost down to ground to 0 volts. But this one with the transistor is not going down to ground. This 1.85 volts. But I believe the minimum voltage on the signal wire here on the signal wire when I'm getting the voltage. These are the voltages that I'm getting. Although it is completely tuning off and tuning on. This LED, which is extremely sensitive to current. So if some current surges was happening here on the signal wire, this LED should have been lit up a tiny little bit, but you can see even in the shadow it's completely off, which is absolutely phenomenal good. It's probably because I'm having this 10 kilo here. So what I did here, I put from this signal point here, I put a resistor, the LED, and connected to the ground rail here, you can see here, and that's it. And I made a flip-flop. Why it is working, and this is an interesting circuit, why it is working as a bistable like that. When one LED is on, the other is off, and when this one is on, the other is off. Why? Because of the position of the LED. So let me draw you a little bit, make you a drawing. So this what is here doesn't matter. What does matter is this section here. So when this LED is auto blinking, remember, when this LED is on, so when this is on, activated, the current is passing through it and is not accumulating anything here, is free. So here is 0. On this side is 0, and this is 1 because it's letting the current pass through it and illuminating the LED. But vice versa, when this is 0, this is becoming 1 because it is like shutting. It's like a contact. It's like a contactor. When this contact is off, it's not permitting any current to flow. So it's open. This contact is open here. So no current here, and you know, like an arrow, but it's crossed. So no current is passing through this contactor or switch here, and all the current is accumulating here on this side, on this node. You see on this node, all the current. Let me actually make some pluses. So all the charge is gathering here on the top. So it's like a box of charges, you know, and everything is gathered here because it cannot pass to the ground. It is open and cannot pass there. So the only way to go to the ground is through this base of the transistor, to this 1 kilo and to the base. So when it's going, it's surging a tiny little bit through there, and this is what is happening. So now, if you understand this part, you will understand. So when this is 1 activated, it is activating this transistor, and this transistor is activated. Let me actually draw the entire circuit because I was lazy. I said I put 10 kilo. This is 1 kilo. This is another resistor, 1 kilo. 10 kilo, a simple LED, like that, and to the ground. That's it. This is the bistable flip-flop. When everything is accumulating here, it's trying to surge through this side here, but also opening the transistor, and in the moment a tiny little bit of current is flowing through the base and through the emitter of the transistor, is opening the transistor and letting a lot of current flow from this side, and thus lighting up this LED. When this is off here, this is on. So this is on, or positive 1, or 1 here. You see, when this is 1, logic 1 or 1 activated, 1. So this is on, this is off, and vice versa. When this is activated, here, everything goes to ground pretty much through here, negative, negative, negative. Nothing passes through this base of the transistor, and this is stopping, becoming a 0, and this is becoming a 1 because because of its internal circuitry that is having there and is lighting up the LED. And that's it. This is how it's functioning. And I have a plan to put another SMD LED 0805. It's the dimension of this, the size of the LED that I'm having here, the auto blinking LED, this size. I really wish I had this 1206 because it's a bit larger and much more easier to work with. But it's all that I got, all that I find at a very, very cheap price. That's the thing, you know. So I will put another LED, probably different color, and I will make an entire new circuitry on another cardboard using this circuit that I'm having here. Basically, this circuit that I'm having here. So yeah, very, very cool idea I had. I was thinking on it, and I said, well, it's good for a movie. So this is a very extremely cheap bistable flip-flop or astable multivibrator, whatever you want to call it. The biggest problem on it is that it is a fixed frequency. You cannot increase the frequency. That's it. And it's good for show, to show something, you know, that is working, or an error that is happening in your circuit. You can make such a bistable circuit, very, very small minimum components required for it. You can make two LEDs, blinking one another for advertisement to signal that is happening, that an error is happening, you know. But it is at a fixed frequency, 1.58 hertz, 1.5 bits per second. That's the frequency that you see here. So it's a little bit of an issue, but if you get over it, if you are fine with it, if it's okay with this fixed frequency and that you cannot modify its speed, then it is good for something, you know, in your circuitry to implement it as it is, you know. And it's stupid simple. It's very stupid simple, and I love stupid simple. I truly love stupid simple. I don't like very complicated circuits actually, but I have the tendency to make very complicated circuits. I forget to mention that this circuit is a test that I'm having here because I already built this module here, so I use it because I have it already built, and I tested if it's working with this LED, and it is working absolutely fine. So this is what you are seeing here is a test circuit, but the next one will be on a single cardboard, not a test like it is right here. All right, the hard part is gone. Hard part meaning making the pads. This is how it's looking on the other side. Is a simple cardboard from medicine, diodes, plus transistors, SMD that are scrapped. All this little box that I'm having here, drawer, is with everything I'm having here is scrapped and cataloged. And so remember, these are scrapped transistors, and I will use only one. I prepared them there in case one will fail. Another very interesting point is here, if I don't want to make it as a bistable flip-flop, so if I'm moving the LED from left side like it is here to the right side here and put the resistor instead of the LED, so I'm switching. The signal will be synchronous with the LED when the LED will get high, when the LED will get lit when it's on. When the LED is on, the signal will be on as well, or high. So it will be synchronous in the same time, exactly in the same time, back, you know, on off. But because the LED is on this left side here, is bistable. I forget to mention this little detail before, but I'm mentioning right now, and it's very, very interesting detail. If you want a synchronous output in the same time with the LED lighting up. All right, so let me make a test for stupidity to see if I'm doing anything wrong. Yep, it's working absolutely cool. Excellent. I'm testing for the polarity of the LED to be sure that I mounted it correctly. And I should have checked the pinout. I will check it right now. So let me put it on diode there. This is how I'm checking. So base, it should be positive here. And here is the base. Good. So base emitter right now, and it's showing me. And base collector, good. And that's it. It's the right, it's having the right, this pin out, exactly this pin out that I'm having it here. So it's standard, which is excellent. It's good. So that's the transistor. Let me check my box of treasures here. Okay, I will use that one. And I said I will use red, and I don't have red. 0805? Really? Oh shit. 0603 then, which is even tinier. Yeah, it's even tinier. Fucking hell! I don't have this this size. Ah shit. I really wanted a red one there. Okay, then I will use that little shit there. And check this out, I have 0402, which is even smaller. Check this out, What a madness I'm having here. Who the fuck? You see that there? You see that one? there is the LED. And I've seen this kind of LEDs actually used in circuits on some boards. From where I was scrapping the components, and I totally destroyed them when I tried to scrap them because they are too fucking tiny. I want this negative sign here to show, not be obstructed. Yeah, it's a bit funky, but it's good. Okay, that's it. The circuit is done. Let me show it up close. And this is it. This is how it's looking. Very cool. You can see actually the markings. W04. Yeah? Yeah. W04 on the transistor. And also on the resistors as well. And also this tiny LED here And you see the difference, the size difference. How big is that? And you can see the chip inside the LED. You see there? So this is the chip. Is having a chip inside that is making it flash, auto flash. It's a small square or cube inside it. It's showing like a black dot, but it's a tiny chip. And the LED itself probably is on this side here, probably, and this is the chip. So it's looking very cute. And that's it. Now I will make the actual test and see if something is blowing up. Hopefully not. Yeah. Oh shit. You see, I'm having some current passing. That's a problem. That's a problem. So that's a problem. Probably the transistor or the resistor. Yeah, it's a problem. It's not shutting off completely. So most probably I'll have to change the resistor with probably 2 kilo or something like that. I'll have to play a little bit to find a proper resistor for this. Let me play a little bit. I was kind of expecting shit like this. I will go to 3 kilo. Let's see now. Hopefully it resolved the problem. Let's pray. Oh shit. No, not really. Oh shit. Maybe it's the transistor? Well, I tried. No, I will change the resistor one more time. Actually, let me make again the experiment here, because I didn't test it at lower than 10 kilo, and that was a mistake. All right. Positive, negative. Yeah, shit. It is possible, but I have to fuck around a little bit. Okay, this is back to normal. So now let's change some resistors. So I'm having 10 kilo, and if I'm adding another 10 kilo in parallel, it will be a 5 kilo. And it is okay with 5. And if I'm adding another 10 kilo in parallel, I will have 3.3 kilo. And it's also fine as well. Huh. Very interesting. No, I can see it a little bit of glowing at 3 kilo. Okay, so, and also on this, no, on 5 kilo then 5 kilo. Okay. All right, so 5 kilo then. Instead of that, 3 is too low. It is still low. Okay, I will change this 3 kilo here. I'll put it here, back to its place. And I will put 5.6. Now, let's see how we are doing. Still, it is still too sensitive. That LED is very, very sensitive. So this means I should change probably the transistor. Okay, so this is leaving too much current through it. Probably it might be it. I will not risk it with this one. I will use 1 IM that I'm having here, because there I use 1 IM as well. This is it. This is 1 IM. So this guy and this guy go back to your cages. Yeah, it's not terrible changing the transistors. Yeah, it's looking okay. All right, let's see now. Please work. No, it's the same. Fuck. Shit fuck. Shit fuck. It's exactly the same as with the other one. So it's not a transistor. Yeah. Probably this white LED is opening and closing is different voltage for this white LED than for the red LED. Red LED, if I'm remembering correctly, are more sensitive usually, and probably that's the problem what I'm having here. It's way too sensitive. If I'm using a white LED instead of this red LED, it will work very close to what I'm... Actually, I can change this with a red LED. Let's see if I'm right. Although they are different, probably different technologies that are used. We will see. And I have to power it here. No, it's okay. It is staying. Let me close the light. Yeah, tiny little bit maybe, but it's not like that. This is very way more sensitive. Huh? Shit. What to do, huh? It is working, but with a little bit of problem. And yeah, see, it's a little bit staying lit. It's still surging through here. You know what? Maybe if I'm putting a larger resistor on the base, because when this is on, this is still on, and it shouldn't be. So I'm getting a little bit of current through this resistor here and opening a tiny little bit. I will change this resistor from the base. So if this was 1 kilo here, I will put 10 kilo. 10 kilo. If this is not working, I'm screwed. Let's see now. No, it's absolutely the same shit. It's still keeping up. Okay, then I'll put even larger resistor because it is still opening the base. So that was 10. I'll put a 20. This was 10 here. I'll put a 22. Let's see now if you are even working anymore. Yeah, it's still working, but it is still opening that LED. Oh, 22. Then bigger. Bigger motherfucker. 50. 50. This was 22 here. Yep, 22. So I'll put double. 56 actually. 56, motherfucker. Let's see now. It's still open. Unbelievable. Okay, so it's still passing a tiny little bit of current through there. Why did that work and this is not? Okay, let me change this resistor here to 10 kilo. And 10 kilo then, but it will be very dim, unfortunately. It's still on. It's still on. Unbelievable. Then I will change the LED. I wished I could put there a red one because it's nice. It's nice color, you know, red and blue. But I believe it's because of the LED. The LED is very, very sensitive at current, especially the red one. 0.3. Tiny little fuckers. And I will put a white one here. Hopefully this will be better right now. This is brand new. It's not scrapped. LED. Now, work. Huh. It's a tiny little bit on. Tiny little bit on right now. It's still on there. I'm not sure why. It's probably. I say it's a tiny little bit on. But it's doing the flip-flopping, you know. I'm thinking to add another one here in parallel, and it'll be less current when it's off. So to put two of them. Let's see. Let's try this idea, and it will eat up a little bit more current when they are in parallel. So another white here. I don't have that much space left. This should be good enough. It's still on. Unbelievable. Unbelievable. Yeah, they are amazingly efficient. Then I will take out this secondary that I just put here. I'll take it out because it's with it or without it is the same thing. It's not really doing anything important, but it was an idea. And I will put it back. And I will change that resistor even higher. So 10 kilo here, even higher value. Then 22 kilo. Yeah, it's still dimmed. Huh. Let me do a bypassing trick. So when it's off, no, it's not good. Oh, you know what? Yeah, it's kind of working like that. Even if you get a, a little bit of current passing through it, a little bit of brightness when it should be completely off, I believe it's okay. I believe it's okay. Although it didn't went exactly as in my tests here. Probably these LEDs that I'm having here are different technology, very different technology from these ones that are SMDs, most probably. It's not that a big problem. I can leave the red one. I can put back the red one as well. This might look, yeah, exactly, good. I find it. Okay, then you know what? even if it's getting a tiny little bit of current through it, because it's this simplistic arrangement that I'm having here, well, it's good enough. It should be good enough. And unfortunately, I wish to be perfect, but it's not. And it's okay if it's not absolutely perfectly perfect. And white 0.8. This was here. Okay. Yeah, it's too weak with the 22 kilo that I'm having there. Let me change it back to like it was before. Okay, and I will put 4.7. Yeah, you know what? I should try it with the opamp instead of the transistor. Nah. Damn it! I really wished it worked with the transistor. So I should link it to the opamp. Let's see if I'm dragging some wires from here to there. Good. So this will be the signal here. So now it should remain completely off. Yeah. All right. This is what I wanted to see. Exactly this. So the opamp is the way, after all, not the transistor. Sucks. Yeah, it's completely off right now. Yeah, you see? It's completely staying off. And I can add a little bit less So now is resistance. So now is 4.7, I believe it was. And I can put back the original 1 kilo and it will bring up the brightness very much, very well. So it doesn't work with the transistor, but it worked here. So it depends on the LEDs that you have, probably. And I will use back 1 kilo. So I borrowed this circuit from here and link only the signal output here, and that's it. That's all that I did. You see, I'm not powering here, but here, using this circuit. Yeah, absolutely brilliantly. So the opamp should be used instead of that transistor. Shit. I will have to remake the circuit and use another opamp, and it will be perfect. It will be perfect. It will be exactly as I wanted it to be. The colors to be blue and red. So see you on the next iteration, on the next circuit. Dang it! I'm very displeased that it didn't work with the transistor. It should have been, because in my test it did work, but I used the exact same transistor here as well. I don't know. These are very, very sensitive LEDs, what I'm having. They are very good, but a bit too sensitive, And this is probably what I tested here was not... it is, these guys are very sensitive as well, but these are even sensitive than these ones. And yeah. Shit. shit fuck. Doesn't matter. It works, but with a tiny little bit of modification after all, with that opamp. It's good that I'm having both of them, for testing purposes. All right. And I'll have to literally build another board like that instead of this. Well, see you next time. All right. So I finished remaking this board. It's similar with this one, as you can see, like that. And it's probably the same size, as you can see, and also like this. It's even smaller a little bit. Now I have to put the components. What was hard, I already made it, putting this pads, metallic pads. Now I will start putting the components exactly as it was before. So I took out everything that I had here with the transistor, and I remounted it here on this new cardboard. It's still a cardboard. I managed to break again my needle. I'll have to remake this tail here, but later, not now. So this is the auto blinking LED, and please don't run away. (102) it's here. So I'm making like a bridge of solder. Let me test, especially for polarity. Yep, it's good. In the distance, is a little bit too much wide. Exactly on the margin is not catching the solder. Yep, it's still working. Good. And good luminosity. I like it. Alright, and now the wires. Okay, this might be okay. I'll have to flatten it a little bit. Here in the margin, no problem. To put it underneath. This is scorched. It got scorched here. Okay. Okay. And now, I believe this is the output. I have the circuit diagram here. Here, LM358. Probably no, between these two, no. From here somewhere. Yeah, the hole is a little bit too big, but it's not touching there. That's the most important thing. So, on the fucking limit, on the very margin of it. And now the ground from here to here. And now theoretically it is complete. Let's see if it's working. I hope I don't mess it up. Not that. No, it should work. It should work. Okay. Maybe this opamp is burnt? Seriously? Let's see. Why don't you work? It might be this opamp is fucked up. Or this side of the opamp is fucked up. Who knows? Yeah, I have to change the opamp now. Motherfucker. This was scrapped. This. And now I'll put a brand new one. Virgin, brand new. Okay. I'll have to test that opamp. I might have burned it today, but I'm working like I'm usually working, not really. Yeah, it wasn't such a big deal to change it, but it should have been worked. And this one is not working either. What the fuck? So it's not the opamp, something else. What is it? Alright, hello again, and this is a happy update. I will talk about two circuits because I had some problem with this one that you're seeing here, in the sense that I used two op-amps that were scrapped from somewhere, from some boards, and I wasn't getting any results. This red LED was not lighting up at all. Only the blue one was lighting up because it's only this circuit here on the top. If you remember, this is a self blinking LED that is doing all this work. This op-amp that I'm using here is only instead of a transistor, so it's only an amplifier. Is amplifying the signal that is receiving from there and transforming it into a more decisive positive, higher voltage positive and very low negative, almost zero volts. It's not actually 0 volts, it's 200 300 millivolts. It's a little bit over the zero, but it's in any sense it is 0 volts rail. So the gap, the distance from the positive and negative is very big, while my other circuit that I did with this one, with this transistor, the difference was very small. So you see it's 4.5 maximum and minimum is 1.8, almost 2. So it's a small difference. It's 2.7 difference. And when I did other tests, and here you see it's 3.5, but I'm not completely sure because I did get two values, two results, 4 volts and voltage minimum 0 volts, or 3.7 and 200 millivolts, like I said, with the op-amp. So this is the circuit that I'm using here, but instead of this signal line, which is the output of the op-amp, on that output I put LED, this red LED with a resistor on it. Let me see if I can find the circuit. So this was giving me a very small difference, but with the op-amp, and I highly suggest to use an op-amp, it will give you a very large difference from the V max and V minim, which is V minim should be 0 volts. So I was not getting this red LED to lit up at all, and I was starting to believe that only the yellow and orange are the optimal, I don't know, signal source. You can collect the source from them and amplify it and make this bistable that I'm having here, FlipFlop. And with the blue and other colors, it wasn't working. But so I had this problem. But the issue was not the circuit or the LEDs. But until I will get there, it was the op-amp. It was the motherfucker op-amp. And that's why I built this op-amp tester, which I have a name here on it, LM358 op-amp tester, specific, very specific for LM358. So here I made a list and I probed this point and I got these results. And I tested, so exactly as you can see it here, I probed it. I only built this tiny circuit here, which is this line from here, positive resistor, the middle point, the LED and the negative. So that's it from here to here, and make abstraction of everything here. I didn't use anything there, and I even disconnected the wire not to be influenced by the rest of the circuit, and this other wire as well, the negative wire. And I did probed, and I tested every blinking LED, a self-blinking LED that I had. So my suspicion was that white, blue and green, they were a little bit different. You see the voltage difference from voltage maximum and voltage minimum. So the difference is 2. Point probably 1, and I was suspecting that this voltage, minimum voltage that it requires, it should have been going to ground, but it isn't. This voltage minimum is when the LED is on, and voltage maximum is when it's off. So when it's off the LED, I'm getting the voltage maximum voltage here on this point, and when it's minimum, it means that the current is passing through the LED and the LED is lit up. That's what it means on this point. So this is the forward voltage of the LED when the LED is lighting up at its full brightness, and these are the values. And I was suspecting when this is for white, blue and green, this minimum voltage is too high for the op-amp to see it, or for the transistor to see it as a low, logic low, you know, like a 0, logic low, and this is logic high. And I was having this problem for a couple of days actually, and then I thought, and I tested the shit out of this, and I even managed to break the cardboard and burn it very badly as much as I tested it. I overheated all the pads and the components. I even burnt one. I managed to overheat actually one blinking self-blinking LED, so I destroyed one. But this is not actually concludent. This is not actually correct in this circumstance, because as you can see, it is working with the blue and the red, while before I wasn't being able to make it work at all. So that's the history. And next, I said maybe what I'm using here, these op-amps that I'm using, maybe one of them are broken in some way. And I said to myself, I should make a tester specifically for op-amps, for this model of op-amp, this LM358 op-amp. And this configuration actually doesn't matter what name is having. If it's having this configuration, the pin configuration that we are seeing here, it's good to go to be tested here. Probably there are other op-amps. I don't know them by heart by any means, but probably there are other op-amps similar with this configuration, pin configuration that we are seeing here. And this tester is for those as well. So these were the two op-amps that are scrapped, and I actually use them here and in other test boards that I made. and also in this one as well. This was with the opamp. And very curiously, I was getting a positive result. Do you see this breadboard here? I took out this opamp. I took it out from here, and I put this LED and this resistor somewhere here, I believe. And I dragged. Let's imagine this is ensembled here, is actually having the chip on it. And I dragged the output, the signal from here. I drag it with a wire to that LED, exactly as you can see it here. But instead of this big one, I use this little board here with this small opamp, and I powered this LED and that resistor. But when I took it out from here and moved it there, it didn't work. And when I tried another opamp here, also scrapped, because I want to use them and get rid of them, it also didn't work, and it gave me another set of errors. So after that, I realized maybe these opamps, this specific two opamps that I scrapped, they are funky. And I was right. I was right to make this board, and I will prove it. I will show you because this is the movie about. Let me mount my phone holder here. This is I'm powering everything with 5 volts all the time. By the way, so I will interrupt from here and from here. I will move this aside, and I will power this from here. Okay, nothing is blinking, nothing is powering up. So this I don't need it anymore. So now let's test this. I already test them, and I know exactly what they are doing. I even marked this one with a black marker on top of the pins here, but here they are making contact very good, very well. And if I'm powering it, if I'm mounting it here and pressing down, this LED is on. So when I'm rotating here, yep, it's good. That input is good, and this input is good. So this op amp here is good. Now let's check this one, and you can see it's not lighting up. It should. It is all this configuration of the potentiometers that I'm having here are set to lit up this LED. So when I'm rotating this potentiometer here, nothing is lighting up on this side, and also this one, when I'm rotating it, also nothing. And I am pressing it very firmly, very flat like that, and it is not doing anything. So this told me that this gate, this op amp here in this right hand, in this right side here, is busted. Is no more. Is not functioning correctly. And it is exactly the op amp that I was, exactly this side I was using in my circuit here, as you can see. And probably I burned it. Probably I overheated it. I have no idea. Probably it was good enough, but for some reason only one side was working. Like I said, I had a very extremely strange results all the time while I was testing. Here it was working with this LED and this resistor on this breadboard, but here when I was putting the SMD LEDs, specifically this red LED didn't work at all. So this is the winner because it's having this this damaged op amp inside. This one, in some tests, I'm not completely sure. Maybe it's not. This is okay after all. This was okay, but I did get quite some strange results from it. I'm not completely sure where I use this. If I use it here on this board when I tested it with that LED on the breadboard, and then I use only this one in this circuit. But this one I don't remember if I use it here. So this is good, even if it's scrapped. And this was bad. So that's this is my update and the proof that this circuit is very necessary for everyone to have it, to check, to compare well-being of your op-amps that you're having. So this was creating a lot of problems for me, and I didn't know why. And yeah, I did have a ton of very strange results. Yep, I'm very happy that it's working now, and it is not an issue of LED color. This problem remained on my mind to solve it. Most importantly, to solve this problem, minimum voltage depending on the color, the signal that I'm collecting from between these two components is dependent on the color of the LED. So this was the very big problem that I was thinking I was having, but it turns out it doesn't matter. It doesn't matter the color, and probably I didn't test every LED here. So let me explain it a little bit. So this is a self-blinking LED, which is having a chip inside, but this is a normal, absolutely normal, simple LED, and it's even smaller than that one, a tiny little bit. And I didn't test. So here I test all these self-blinking LEDs, this in this list here. But here I didn't test all the LEDs that I'm having, the normal ones, with every color that I'm having, because it was a quite extensive test. So I didn't do it. But it should work with, theoretically, with every kind of LED, every color. But be mindful that this opening voltage is a little bit of problem, especially when you are using this transistor circuit, which is also working fine. You can power something with it. You can collect the signal from it, but you must have a very sensitive input to actually see this signal here. So this is a little bit different, a tiny little bit different than this. This is a little bit better than this because the signal is more complete, more definitive high and more definitive low. That's the reason I used this op amp here. And this is it. This is all my tests that I did, and this is all that I wanted to explain. All right, I managed to make it with the transistor actually. Is this circuit here, and here on the signal line, which is the emitter of this NPN transistor, which is this pin there. You know, if you take this transistor and rotate it like this, this is the emitter, and I put here a resistor. 1 kilo actually is there. It's not 10 kilo. It's 1 kilo, and I don't have a circuit diagram unfortunately. Is this circuit here? It's like this from here to the ground, and you can actually see a tiny infinitesimal little dot of light when it should remain completely off. But that is I really don't care about that extra tiny, super tiny little dot there. The idea is that it is working even with 1 kilo completely fine, without the LED staying too much lit up when it should be on logic 0, on off state. So what I did, after I made everything, after I made all the tests, all the errors that I had, after I made the opamp circuit, which is this one here, which is working fine, by the way. But then after I in the time I was editing my movie, and I rewatched my entire edited movie, and then I realized maybe what I didn't do. Well, I observed that I changed the transistors, but I changed them between the scrapped ones. So, but I didn't took the new transistors from my arsenal of new transistors. I didn't test an absolute new transistor like this. This is the 1IM that I'm using usually, and I didn't took it absolutely brand new from there. I took it already used, and I didn't test too many transistors between them. I only tested 2, maybe 3, but I don't remember the third one. So most probably only 2 transistors between them, and they were already scrapped, already used, already most probably thermically and electrically stressed in the circuit they come from. And probably when I took them off the board, most probably I stressed them myself thermically when I was desoldering them. But this guy here is the one that it was here on this board, and this guy that is right now is brand new, completely virgin. And this too, I believe this is brand new as well, because there is no much difference. This I'm getting exactly the same output as for this yellow LED here with this transistor and with this other transistor that it was before it. And so it was before it, and then I said, let me change it. Maybe I will not get that little tiny little shit there, but I still get it with a brand new virgin transistor there, absolutely new. So that's a very important lesson. I'm not completely sure how to test. So this is a big problem for me, because some transistors are opening but not totally, or semi-opening, or it's like that. It's a kind of opening. It's not they are not opening fully. They are only a tiny little bit. They are weakened. Some transistors are weakened, some transistors that are used, of course, and I don't know how to test that weakness they have inside them. I didn't concentrate enough in my life to find a solution for this kind of weakness in the transistors and to test them. But with this circuitry that I built here, I kind of start to realize that it's time to make a testing device, a testing circuit specifically for testing the weakness in a transistor, how weak it is. And I'm not completely sure how I will do it, but I have an idea. But suffices to say, with this experiment that I'm having right now, it is working flawlessly. If it's not 100%, it is 99% in working operation. Because of that little dot there, I will take out 1% from the 100%. It is 99% in good working condition, and you will get. I'm getting this flip-flopping effect or logic that is happening here. Unfortunately, like I mentioned it to death already, this is a fixed frequency. You cannot change it. It's only this and that's it. It's 1.58 hertz, or better said, 1.5 bits per second, to make myself understood by everybody. So it is working actually with a transistor, but you have to use a very good transistor and also a very good LED, most probably. Everything to be new, not scrapped like I used before. So that's an very interesting lesson to myself and for you as well, hopefully. So that's why this circuit, actually only this part from here, from when I took the signal from this pad here, without this thing that I added just today, but this was only with this signal pad here, and I took the wire and I put it somewhere here, only to this LED and this resistor without this opamp here. This remained from other tests. So I dragged the wire and I put it there and I tested it with this LED in the beginning of the movie actually, and it worked completely fine, flawlessly. It worked absolutely gorgeously, like it is working now. But the difference from this circuit that I had before and the other circuits that I built after was the transistor quality. So these are absolutely brand new transistors that it had absolutely brand new transistor. And what I used after that, I used a little bit fucked up transistor and already used transistors, and that's why it worked here, but it didn't work in my experiments that I had, and that secondary LED remained lit up while it should be off. Another point is that what I really like about this circuit and why I insisted to make a flip-flop from it and push it so hard to make it work, despite all of the bad luck I had with the bad transistors, is the size of it. It's very, very tiny and very few components, and it's super simplistic, and it's very cute. That's the thing that I really like about it. All right, that's it for this part, and thank you very much for watching, and see you later. And I hope you like your favorite artist electronist, Mr. Q12 here. Bye bye.